I did a video on this ages ago. People were wondering what the heck these artifacts are that appear in the mimic imagery. Right here. See that? There's been several different kinds of anomalies that have been seen in the mimic imagery. These images are produced by the Cooperative Institute for Meteorological Satellite Studies. If you take all of the water vapor throughout the atmosphere and you caused it to rain out, it would indicate the approximate amount of moisture that would fall out as rain, where red and brown and orange represents higher levels of precipitable water, and blues and purples and these colors over here represent virtually no precipitable water. So they obtain these images from a bunch of different polar orbiting spacecraft that orbit the Earth over the poles. I'll go into that in a moment. Each of these spacecraft have passive microwave sensors, and these sensors are capable of seeing microwave wavelengths. So they're looking at the Earth at these microwave wavelengths at frequencies of 19, 22, and 37 gigahertz. Currently, the data is obtained from approximately 7 polar orbiting spacecraft, such as the DMSP F-18 spacecraft or the DMSP F-17 spacecraft. They all have these sensors on board that passively see the microwave radiation coming from the Earth. So the data that's provided from these spacecraft are used to form these pictures, frame by frame by frame. Now, before we can really understand how these are put together and the anomalies that are caused, we have to understand what a polar orbiting spacecraft is. So to do this, we're going to use the satflare.com website and track the DMSP F-18 spacecraft in real time. So what is a polar orbiting spacecraft? A polar orbiting spacecraft is a lower altitude spacecraft that orbits the Earth over the polar regions. You can see the orbit here in the red line. This is the path that the spacecraft is taking, or going to take rather, through space and across the Earth. You can see the path here. It's traveling in this direction here. So it's going towards the Antarctic, and then it'll creep back towards Australia and into Asia and up over close to Iceland, and then back down through South America again over the next pass. You can also see the view of the spacecraft from a realistic view of the Earth here. If I manipulate this around, you can see little white dot here. If you follow that, you can see that that's that spacecraft that we're tracking right now. Okay, so that spacecraft is a polar orbiting spacecraft. It goes near the poles. So here it's going to go near the South Pole, and on the next pass, if I can get this oriented right, it goes near the North Pole here. Polar orbiting spacecraft are useful because they can see swaths of the Earth at much higher resolution than a spacecraft such as a geosynchronous spacecraft, which is so much further away from the Earth. To give you an idea of what I mean here, let's look at a swath that is cut by the Aqua satellite. So what you're going to see is the spacecraft simulated to be moving above the Earth and towards the North Pole, and as it does so, you'll see the swath of the ground that the spacecraft is able to see as it moves in its orbit. So here you can see the spacecraft moving above the Earth, and it's seeing this part of the Earth, only that little swath of the Earth, but it sees it in incredibly high resolution. And then as the spacecraft goes around the Earth and comes back into view again, it cuts another swath. Now notice that the swaths don't always see every bit of the Earth. There's some areas where it can't see because the orbit does not allow it to see some parts of the Earth here. But on these initial passes through, you can see that there's portions of data that are missed. Part of the land is not imaged here. That's really important to remember, because it's a common trait of most polar orbiting spacecraft. It depends on their field of view of their cameras and their sensors. There will be data gaps like this. Now if we go back to this image here, you can see that there's no data gaps. You can't see any. And part of the reason for that is because they're using many polar orbiting spacecraft to try and fill in the gaps. But this is a really complicated process that they do every single hour, every single frame that they produce one of these images. So here's a single swath from the DMSP spacecraft as it travels around the Earth. Just one swath, because it takes time for the spacecraft to create these swaths, right? Every single time it has to go all the way around the Earth before it can create another swath. Because it takes time for these swaths to happen, there has to be a way to take this individual swath here and merge it in with the other swaths in order to create a movie like this. But this is not a really simple process, because this swath is going to change over time. The precipitable water that you see here is not going to just stay stagnant and stay there like this hour after hour after hour. It's going to move because the winds push the moisture around. So in order to compensate for that movement, the people who created these movies had to come up with some sort of an algorithm that would make the water vapor move in accordance to the wind fields that are observed in that area where that swath was created. So in this swath, there's winds all over the surface of the Earth here that's moving these moisture packets around, correct? So what these clever people did was they took wind field data that from other instruments and other observations, and they applied them to these images, so that over the course of time, these parcels of vapor and these pixels representing moisture would be moved and morphed into different shapes and patterns depending on the wind fields that are in these areas. So let's look at how that process happens here. Here, in black and white, are the wind fields, and the colored picture here is the original swath that we saw, and it's being morphed and changed in shape according to the orientation and magnitude of these wind fields. So stronger winds are going to push the moisture in the direction of the arrows more rapidly. Over time, this entire parcel, this entire swath that is seen by the DMSP spacecraft is morphed into a completely different shape by these wind fields. You can see the time here in hours being shifted, and so they're using this method of changing the location and shape of these pixels in this image so that it can reasonably well simulate what the actual moisture content will look like on the surface of the Earth over time. They have to do this, because if they don't do this, then they're not going to get a nice fluid moving movie of the moisture content in the atmosphere of the Earth over time when they animate everything into these movies. But in order for this to work, they have to have many different spacecraft producing these swaths of information that they can then apply these wind fields to in order to get these global maps. So here's an image of all of the spacecraft that participate in creating the movie that everybody misinterprets. You can see them here in colors. The DMSP F-18 would be in brown, the 17 spacecraft would be in red, and all these other spacecraft, NOAA 18, NOAA 19, they all contribute here. And you can see the colors of this and the width of the swaths of data that they produce for this movie. So every time you see a swath here, like this blue one, that's coming from the N-19 spacecraft here. Every time you see a deep blue one, it's coming from the N-18 spacecraft, the NOAA 18 spacecraft here. So this one is the NOAA 18. The movie is moving because as time passes, the spacecraft take different swaths over the Earth. So what happens when data is missing? Say the swaths don't quite overlap. Well, then you get a situation like this, where you get these gray areas that show up in the image. See that? These gray areas are areas where there was no data available because no spacecraft was able to cover that area, swath it, and read the information. So they have to interpolate the data. They have to fill in the data gaps with whatever they have. no matter how old it is. They have to fill it in with something so that you get a smooth movie as is shown here. But you can see where some of those data gaps occur, because you'll see little, right here. See this? This is a data gap that they slowly fill in with more information until the swath is covered with new information from another satellite pass. See right here? You can also see these wave-like shapes here kind of propagating across the actual final map, the actual final movie. So pay attention to the shape of these things here. Here, look at the final movie. You can see, it's really kind of tough to see, but if you watch really carefully, you can see them moving across, almost wave-like. This is what has caused so much confusion amongst everybody who doesn't understand how to interpret this information. They look at these wave-like things and they think, oh my gosh, the world is going to end. But it's just these swaths of new information that are appearing from the spacecraft that are going across the Earth in these polar orbits. That's all it is. If one pass by one spacecraft produces data that is just slightly less intense than another spacecraft, it will produce a slightly different shade of colors as it's coming across here. The guys who've made this movie and incorporated and processed the data have actually done a fantastic job trying to normalize the colors so that you don't see these artifacts very well. But this is all part of the process that they have to go through in order to produce these moving pictures. It's almost impossible to get rid of all of the artifacts. So anytime you see waves appearing in those mimic images and movies, you now understand that it's a loss of data or a gap in the data, such as here, caused by the spacecraft that are orbiting in these polar orbits. It's just a loss of data, and they try to make up for it by morphing the data. Even the morphing can cause problems. For example, this is the shape of the swath. You'll notice that the lines here are curved according to the curvature of the Earth and the field of view of the spacecraft. But as soon as you try to accommodate the passage of time by morphing this according to the wind fields and how they're blowing the moisture around, you can get these really odd, wonky shapes here like this. So these changes in the shape of these swaths can also introduce areas where there is no coverage. For example, this area right here. If there wasn't a nearby swath to this one over here, where my mouse is going up and down over here, if another swath from another spacecraft did not produce data that was close enough, it might cause a gap in the data as this parcel here is morphed and changed in shape according to the wind fields. So that kind of data gap that I just talked about is something that can be shown and seen right here. Right here. See that data gap there? That might be explained by these morphing winds that introduce areas in this area right here that can't be covered. The weird lines that you see here are related to the spacecraft that's actually producing the swath. That's probably bad spacecraft data. But you can see that it kind of comes down towards the polar region and then it comes back up. That's the spacecraft moving down across the poles and coming back up, just as is the case here. The DMSP spacecraft went down, crossed over the pole, and is coming back up. And it's in this same wave-like shape, see? When you take the Earth here and you flatten it into a flat map, orbits become sine waves, like this. This black line here is the sunrise sunset terminator, or this band here where the sun is rising and setting. Okay? That's what this black line is. But the point is, this spacecraft is moving in this direction, right? Just as the anomalies that you see here move in the same direction. So this is just an area where bad satellite data was being received and they were unable to account for it. And as soon as the data was received, then the dots start moving and being processed as though they're valid data when they're not. And you can actually see them being morphed according to the wind fields. The winds down here are moving from east to west, right? If you watch the dots as they cross this area, you'll see that for the fraction of a second that the dots are visible, they start getting morphed according to the wind fields. You can see them being pushed and moved around by the algorithm that these guys are using to maintain these images so that they are fluid. If they didn't do that, these images would look horrible. So if you do a Google search for a mimic anomaly, it pulls up a plethora of bad images that were produced because of exactly what I've explained to you. And there's a slew of YouTubers who've tried to make a fortune off of these anomalies. Dutch Sense is one of them. BP Earthwatch has been really bad. Mr. BBB333 or whatever that name is has been also getting worse. And tons of other people, including people like Secure Team 10 and tons of other people, they've been completely misinterpreting the information and fear-mongering, telling people that these things are being caused by solar flares and that they're responsible for earthquakes and other ridiculous things. It has nothing to do with the sun. It has nothing to do with earthquakes at all. It has everything to do with what I have just explained to you. So if we look at a few of these, we can now begin to understand what's going on. Here's an example where a spacecraft was producing bad information, and it was being picked up by the algorithm and improperly taken as though it was real data. The orbits of the spacecraft you can clearly see, and the swath of information that the spacecraft produced is also clearly visible. They've blacked out the area that goes over land. They just want to provide the information for water content over the ocean. So they've taken the land mass here and they've plopped it over top of the image to hide the actual part of the image that is not over the ocean. Here's another image where the information from the spacecraft was incomplete and the algorithm that is trying to move these parcels of information leave data gaps. And here's an image from a guy who's trying to relate these weird things to activity on the Antarctic ice shelf. I mean, it's ridiculous what they try to do just because they don't understand what is going on. They don't understand how these images are put together. And this is a good image because it shows the path of one of the spacecraft as it's going on its polar orbit. Now look, see, it's going right towards the poles on both sides. Same with here. The swath is going towards the poles on both sides. And they've wrapped this image around a globe. It has nothing to do with energy waves or anything of that nature. That is garbage to the max. And here's an example of what might be seen if the wind field information upon which these movies are reliant fails. If there's insufficient data for the wind fields, it can produce weird anomalies like this. I can also see other artifacts here. Here's a swath of data that doesn't match up quite right with a swath just below it here. See how it changes here? Another one right here. There's another swath here I can see, and another swath here I can see. I can tell that they're swaths because there's a sudden change. Right here there's a division. And they're oriented in exactly the right direction because they're polar orbiting spacecraft. They're going towards the poles. And here is an area where wind field information is all screwed up. And over here is an artifact caused by the advecting of the information, the morphing of the information from the wind fields causing a gap here that can't be completely filled in. This right here is called advecting. They're advecting the moisture profile using the wind fields. So there's tons of reasons why these images might have artifacts in them. So now you know. I think BP Earthwatch owes me a cap or something now because he challenged everyone to explain why these things happen. And those people who are misinterpreting the information and using it to fearmonger should be ashamed of themselves. I mean, come on, it's right here on their website. Product description. It's right here. All they have to do is read it. And if you don't understand the words, grab a dictionary and look it up. And if you still don't understand, call the guys who actually do it and ask questions instead of pretending to be an expert like so many of these people do. So anyway, now this is settled. I highly doubt if enough people are going to actually listen to this and understand it, let alone probably even believe it. They'd rather believe that it's produced by some alien spacecraft peeing on the planet or something. It's not. Nothing weird is going on. Relax, everyone.